Hi, my name is Alor Cavazos, and this is my test problem for my discrete math class, and it is chapter 2, problem 21. So I feel like just reading the problem is going to take the longest. So we have evaluate the sums as S of n is equal to as the sum of -1 to the n minus k as k goes from 0 to n. We'll say comma. And then we have Tn equals as the sum of -1 to the n minus 1 times k goes from 0 to n, comma as well. And then we also have as the sum of -1 to the n minus k times k squared as k goes from 0 to n. And that is equal to u sub n. By the perturbation method, assuming that n is greater than or equal to 0. So, what is this method? Look at this. It's an example. It's not really simple in my opinion. It took me a while to really figure this out and understand it, and to apply it to all these other problems. We have this one. I'm just gonna call this one because reading it all out, it's gonna take up a minute. So in order to perturb something, we have to extract the first and last terms of cube n plus 1 in order to get an equation for cube of n. So here we just we split off the first term, and this is what the last term would look like. Now it's better to look at this with actual numbers rather than just letters or just a regular example. I think as I start showing you the math and everything, it'll be easier to understand. So this is the first equation. So we have, this is S sub n equal to as the sum of -1 to the n minus k as k goes from 0 to n. So this is our first term, this is going to be our last term, and this is going to be our closed form. I also have these on the same, for each equation that I did, it'll be the same setup. This box will be the first, this box will be the last, and this one will be the closed form. And for the closed form, you just have to get it. Just do some simple algebra over here to do that. So anyways, first term, so we set it up equal to n plus 1. And we basically just added plus 1 to most of the terms in here. And then as you follow along, you could definitely see the math and what's going on. But once we get lower here, we can see that this, as we added 1, right here, this is that, which makes it a lot easier. So we have S sub n plus 1 is equal to -1 to the n plus 1 plus Sn. We want to remember this as well. This is our first term. Well, now we extract the last term, or the final term, or the one, however you want to read that. So then we also set it up to S sub n plus 1 equal to that, and then that's what we get. I thought I had to step away, because of course I had to sneeze. I swear I do that the worst times. So we split up the last term, and then we ended up down here. If you just follow the math, you'll definitely understand it. So this right here is S sub n, and obviously not including the negative, just this part. So then we have S sub n plus 1 equals negative S sub n plus 1. So now to find the closed form of that, we set these equal to each other. So we have -1 to the n plus 1 plus S sub n equals negative S sub n plus 1. Then we solve for S sub n, which we get 1/2 times 1 plus -1 to the n. But if we want to remember this, now let's look at our second equation. Again, same thing. We just did same thing, just second equation. We have the first term, last term, and closed form. So we are literally doing the same exact thing. And then as we continue to go on with the math, we find that this is actually right here. And now you're thinking, oh, if it worked for the first one and it worked for the second one, it might work for the third one, as we'll see in the next slide. And then we see that this is S sub n. So this is technically t sub n plus s sub n, which is really nice. I'm glad this wasn't that complicated. And then as we split off the last term, we have t sub n plus 1 is equal to all of this. And then we finally end up down here, and so t sub n plus 1 is equal to negative t sub n plus 1. So then we do a closed form as well, just as we did the first equation, and we set them equal to each other. And this one required a little more math. So at the bottom, we finally get t sub n is equal to 1/2 times n minus negative 1 to the n. And that is looking familiar. It's a good thing we're getting the 1/2. It is a really good thing. It shows that we're on the right track. Now for our third equation. Here's our third equation up here. Again, we have the splitting off the first term, splitting off the last term, and then the closed form down here. So first term up here, we did all of that. Now I'm noticing I don't really need to include the 0 here just for the clarification. So as we get lower here, we are getting, this is u sub n, this is that. We get t sub n, we also get s sub n. So we are definitely on the right track, thank goodness. So now we have u sub n plus 1 is equal to u sub n plus 2t sub n plus s sub n, because we have this 2, we can't forget it there. I forgot it there for the first time, and I was out of whack. So now we have the splitting off the last term. So we are basically doing the same thing over and over again. And so we have this equal to all that. So we have u sub n plus 1 is equal to negative u sub n plus 1 squared. So then we do the closed form again. We set these two equal to each other. And we get all that, do the distribution and everything. So we get u sub n is equal to 1/2 n squared plus n. Again, the 1/2, I'm seeing a pattern, thank goodness. And so, after all that, that is what we get. And I think that's the correct answer. I think it's the correct answer. But I'm seeing a really good pattern here. All right, and we solved the problem, or at least I hope so. At least we hope we did. Thank you for watching.